Hello viewers, welcome to UN Digital Class. In today's lecture, I am going to discuss about key management. Let us start. Key management refers to managing cryptographic key in cryptographic system, which means key management is nothing but it is the generating, exchanging, storing, using and replacing keys at the user level. That is called the key management. In cryptography, key management is the most important part because here when two parties, suppose the sender and receiver, wants to communicate or share some secret information, at that timing the sender and receiver must use some encryption and decryption algorithm with key. Here, if the key is known to the attacker, that means the attacker can easily get the information that is shared between the sender and receiver. Which means if the key is shared between the sender and receiver in a secure manner, that means the attacker cannot get the key. To achieve this security, different key management techniques are used. First one is the symmetric key distribution using symmetric encryption. Here in symmetric encryption, always the sender and receiver use the same secret key. And that secret key must be shared in a secure manner between the sender and receiver, so that the attacker cannot get the secret key from the network. And here, for achieving this security, frequently the key changes are required, and here the strength of the cryptography depends upon the key distribution. Now look at the key distribution. Suppose there are two parties A and B. Here A is the sender and B is the receiver, and these two parties wants to communicate by using the symmetric encryption. That means here A and B use a same secret key for encryption and decryption. Now look at the different ways how the secret key is shared between the sender A and receiver B. First method is A generates the secret key and physically delivered to B. Then second one is a third party generates the secret key and delivered to the two parties, that is A and B. In these two cases, the secret key is physically delivered to the sender and receiver. That means in the first case, the key is generated by one of the parties that wants to communicate with each other. And in the second key, here the key is generated by the third party, which is trusted by the sender and receiver, and that third party generates the secret key and it's shared with the sender and receiver. In both the ways, the key is shared physically. Now look at the next method. Here in third method, suppose A and B communicated previously by using some secret key. That means here the A and B communicated by using a secret key, and that key is the old key. Now A and B wants to communicate by using some new secret key, which means here A generates a new secret key and it encrypts that new secret key by using the old secret key and send it to the receiver B. Now the receiver B receives the encrypted message from the sender A. Now the receiver B decrypts that message by using the old secret key, which is already shared between A and B. After decrypting this message, then the receiver B gets the new secret key. After getting that new secret key, now the sender A and receiver B communicate by using the new key. That is one method of distributing the secret key between the sender and receiver. Now look at the another method. Here in this method, A and B have a secure communication with third party, suppose C. Now, the third party C generates a secret key and it sends that secret key to the sender A and to the receiver B. That means in this case the third party generates the secret key and share that secret key with the sender and receiver. These are the 4 different methods how a secret key can be shared between the sender and receiver in secure manner. Now look at the key distribution scenario. In this scenario, this is the initiator A, that means this is the sender, and here this is the responder B, which means this is the receiver. Now this is the key distribution center, that is the KDC. In this scenario, assume that each user share a unique master key with the key distribution center, that is KDC. Next, assume that the user A wish to establish a logical connection with the user B. Now, A has a master key, that is KA, and that KA is only known to itself and the key distribution center KDC. That means here the initiator A and key distribution center KDC share a secret key and that key is the KA. In the similar manner, B share a secret key with the KDC, that is the KB. Now look at the step 1. Here this one is the step 1. In step 1, A issue a request to the KDC for a session key to protect a logical connection to B. This message includes the identity of A and B and a unique identifier N1. Here the identity of A is represented by ID A and identity of B is represented by ID B, and N1 is the unique identifier which is referred to as nonce, and that nonce N1 may be timestamp, a counter or a random number. Now look at the second step. Here, when the KDC get the request from the initiator or the sender A, after that the KDC send a reply to the initiator A. Here the KDC responds to the initiator A with a message encrypted by using the key, that is KA, which is a secret key shared between the initiator and the KDC. That means here this encrypted message is only decrypted by using the initiator A. Now look at the message. The message includes, that is KS, which is the one-time session key. Then next it contains the original message that is sent by the initiator A. Then next it includes message for the responder B, and that message is nothing but, that is also encrypted message, and this message is encrypted by using the secret key KB, and it also contains the secret key, that is the session key KS and the ID of A, which means this message is nothing but it is an encrypted message, and it first encrypt the message and it first encrypt the session key and the original message by using the secret key KA. Then it encrypt another message, that is the session key and the ID of A, by using the KB. Now the initiator A receives this message. Now look at the initiator. Here the initiator send the message to the B, that is the responder B, and the message is nothing but, that is the message which is received from the key distribution sender, and that message is encrypted by using the secret key KB, which means here this message is only decrypted by the responder B. The responder B receives this message. After receiving this message, then the responder B send another message to the initiator A. Now look at here the message is the secret key KS and another unique identifier N2. These two things are encrypted by using the secret key KS and send it to the initiator A. Here, when the initiator A receives this message, then it uses the same secret key KS and use a function F with the unique identifier N2, and after that it sends it to the responder B. Now look at the first three steps, that is the step 1, step 2 and step 3. These three steps are used for the key distribution. Here the step 4 and step 5, these two steps are used for the authentication, because in first three steps the secret key is shared between the initiator and the responder. After sharing the secret key, then these two steps are used for the authentication of initiator A and responder B. Next, another method is symmetric key distribution using public key encryption. Previously, I have discussed symmetric key distribution using symmetric key encryption. Now, here this is the symmetric key distribution using public key encryption. Here the public key encryption is inefficient. That means this public key is not secure for direct data encryption. For this reason, the public key encryption is basically used to encrypt the key for key distribution. Next, simple secret key distribution. This distribution is proposed by Markle. This distribution allows secure communication, and here no keys before and after exist. Now look at the scenario. Now look at this figure. In this figure, A is the initiator or the sender and B is the responder or receiver. Here, A generates a key pair which contains its public key and private key, and the public key is the PUA and the private key is the PRA. After generating the key pair, then the A sends its identity, that is IA, and the public key PUA to the receiver B. When the receiver B receives the public key of A and the identity of A, then B generates a secret key, that is KS. After generating the secret key, then B encrypts this secret key KS with the public key of the initiator A. After encrypting this secret, then responder B sends it to the initiator A, which means here A receives a message from B and this message contains the secret key KS, which is encrypted by using the initiator public key or A's public key. When A receives this message, then A decrypts this encrypted message by using its private key, that is PRA. After decrypting this message, then the initiator retrieves the secret key, which means after decrypting this encrypted message, the initiator A also gets the secret key KS, which means here the KS is only known to the initiator A and the responder B, because this encrypted message can only be decrypted by using the private key of the initiator A, and here the private key of initiator A is only known to the initiator A, so that this secret key KS is only known to the initiator A and the responder B. After decrypting this message, then the A discards both the private key and the public key. This is all about the simple secret key distribution. But in this simple secret key distribution, there is some problem or some limitation. Now look at that limitation. That limitation is nothing but that is the man in the middle attack. Now look at this figure. In this figure, Alice is the sender and Bob is the receiver, and here Darth is the third party or the attacker. Suppose the Alice wants to communicate with the Bob. That means here the Alice and Bob share the key for the communication. First, Alice generates its key pair. That means Alice generates its private key, that is PRA, and the public key PUB. After generating the key pair, then Alice sends its public key and identity to the receiver B. But here, when Alice sends its public key and identity, in the middle, that means in the network, there is the attacker Dept who takes this public key and the identity of A. After taking these two things, then the attacker generates its own key pair. That is its own private key PRD and public key PUD. After generating its own key pair, then the attacker sends its own public key and the identity of A to the receiver Bob. That means here that is the PUD, public key of the Dept, and IDA, that is the identity of Alice, sent to the Bob. When Bob receives this message, then Bob also generates its key pair, that is its private key PRB and public key PUB, and it also generates a secret key, that is KS. After generating the secret key, then Bob used the public key that the Bob received. That means here the Bob receives the public key, that is the public key of Dept. Which means now using the public key of Dept, it encrypts the secret key KS and send it to the Alice. But before reaching this message to the Alice, the Dept take this encrypted message. And here the secret key is encrypted by using the public key of Dept. That means this encrypted message can be decrypted by using the public key of Dept. Now Dept decrypt this message by its own private key and generate the secret key KS. And it kept that secret key, and again it encrypts that secret key by using the public key of Alice and send it to the Alice. When Alice receives this message, then the Alice decrypts this message by using its own private key and get the secret key. But here Alice and Bob are unaware that KS also known to the attacker Dept. That means when Alice and Bob share some secret information by using the secret key KS, then the Dept, that is the attacker, who also knows this KS, that attacker takes this message or decrypt this message and get the message from the network, which means this key distribution is not a secure key distribution. Now look at the secret key distribution with confidentiality and authentication. Now look at this figure. In this figure, this is the initiator A and this is the responder B. That means here the initiator A wants to communicate with the responder B. In the first step, the initiator A uses B's public key or responder public key, that is PUB, to encrypt a message that contain the unique identifier N1 and the identity of initiator A. That means in this message, the initiator A takes a unique identifier N1 and its own identity ID A and encrypt these with the public key of responder B and send it to the responder B. Now the responder B receives this message. After receiving this message, the responder B decrypts this message by using its own private key. Now look at the step 2. In step 2, the responder B uses the public key of the initiator A, that is PUA, and encrypts the unique identifier N1 and N2. Here the unique identifier N1 is generated by the initiator A and send it to the responder B. And N2 is the unique identifier which is generated by the responder B. That means when the responder B receives this message, from this message it takes the unique identifier N1. Then it generates its own unique identifier N2. After that it concatenates both the unique identifier and encrypt these unique identifier by using the public key of the initiator and send it to the initiator A. Which means in this message the unique identifier N1 says that the message is received by the responder B, and the N2 says that it is nothing but it is the acknowledgement of the responder B. Now look at the third step. In the third step, the initiator A encrypts the unique identifier N2, which is generated by the responder B, and send it to the initiator A. Now the initiator A receives this message, and from this message it takes the N2 and encrypts this N2 by using the public key of responder B, that is PUB. Then send it to the responder B. When the responder B receives this message, then it decrypts this message, and after decrypting this message it gets the N2, and that N2 must be matched with the N2 generated by the responder B. If this N2 is matched, that means the responder B is confirmed that this message is coming from the authenticated initiator A. Now look at the fourth step. In the fourth step, the initiator A generates a secret key KS and encrypt this KS by using its own private key PRA. After encrypting this message or this secret key KS, then it again encrypts by using the public key of responder B. After that, it sends it to the responder B. When the responder B receives this message, first the responder B uses its own private key and decrypts this message. After decrypting this message, it also gets another encrypted message, that is the encrypted message of secret key. Here this secret key is encrypted by using the private key of initiator A, which means this message is decrypted by using the public key of initiator A. Now again the responder B used the public key of initiator A and decrypt this message. After second decryption, it gets the secret key. Now look at here when this message is transmitted over the network, if the attacker gets this message, then the attacker must decrypt this message. For decrypting this message, the attacker must have to know about the private key of responder B, because this message is encrypted by using the public key of responder B, so that the attacker cannot get the private key of responder B, because the responder B only known its own private key, so that the attacker cannot decrypt this message to get the secret key, which means it satisfies the confidentiality. Now look at the second decryption. In second decryption, it must require the public key of the initiator. That means here the responder must know that this message is coming from the initiator A, which satisfies the authentication. That means this is the technique of secret key distribution which satisfies the confidentiality and authentication. Next one is hybrid key distribution. In hybrid key distribution, it uses the key distribution center, that is the KDC. That means in this technique, the KDC generates a secret key and its share between the sender and the receiver. That is the hybrid key distribution. The hybrid key distribution provides the rationable, that is the performance, and the backward compatibility, which means in hybrid key distribution, it always uses a key distribution center, and that key distribution center generates a secret key, and as per the request of the user, it shares that secret key between the sender and the receiver. This is all about the symmetric key distribution. If you have any doubt regarding this symmetric key distribution, then you can ask me through comment. I will reply you and discuss about your doubt. In my next lecture, I will discuss about the public key distribution. Thank you for watching.